Hey guys, so today we're going to be talking about creating and solving equations, but before we do that, we're going to go over the last chapter or the last part of the second chapter, which was called modeling equations, and we're going to do one question from that part in order to have a review. So this question is, a student is given the rectangle and square shown below, which I will draw in a minute. The student states that the two figures have the same parameter. Is the student correct? So there are two rectangles drawn below. And for this first one, it's x by 4. And the second one is actually square. And it's x plus 2 and x plus 2. So they're asking if the parameter of this is the same. So how are we going to do that? It's the same thing we did in the last video with modeling expressions, apples and oranges, right? In this case, there's only apples here. So pretend like it's two different. So in this case, it's just apples. So you're allowed to add them together and compare them together. So since it's a parameter, you add all four sides. So these two are the same and these two are the same. So this is also x. This is also x plus 4. Same thing goes here, but I think you get the point. So it would be x plus 4 plus x plus x plus 4 plus x. Now we just want to equal it. So what are all of these x's going to give us? It won't give us x to the fourth, it'll give us 4x, because you can only get x to the fourth if you're multiplying 4 x's together. But since we're just adding them, it's like a number. So pretend x was 1. So if x was 1, then it would just be 1 plus 1 plus 1 plus 1, which is 4 times 1, right? So it's 4. Like that, except we're just doing 4 times x. And then we have to add right here, the 4's together, which is 8. So that is the expression for the perimeter of the first rectangle. So now we're going to see if this student said the statement correctly, where this is the same, it'll come up as the same thing. So we're just going to do x plus 2 plus x plus 2. Also, I should have added parentheses. Because there are 4 sides of a square, so you just add 4 of them. And so in this same thing, we can count that there are 1, 2, 3, 4 x's, and we can count that there are 4 2's, so 2 times 4 is 8. And we got the same thing, so the student was correct. Okay, now we're going to go on to creating and solving the equation. So for this first example, we're just doing a little bit of a multiplication. So it's like PEMDAS. So PEMDAS is parentheses, exponents, so that square up there, multiplication. Sorry. Let me start over. Okay. It's just parentheses right there, exponents, multiplication, division, addition, subtraction. So the problem, or not the problem, but the purpose of PEMDAS is to show that you do these things in order going this way. So basically, in an equation, you could say these two are the same, so you would do these last. You would do the multiplication and division, and you would keep parentheses and then exponents. So you want to do these things in order to get the correct answer. Because let's say there was a random equation which had the exponents, it had the multiplication and addition. If you had like an equation where it's 2 squared times 4 plus 3. You can't even tell what this is without parentheses, right? So in order to solve this, you would first need to do this and then multiply it together by this and then add it plus 3 to get the correct answer. Because what if you just did 2 squared is 4, and what if you just did times 4 plus 3? 12, 48, right? But then here, it's 4 times 4, which is 16, plus 3, which is 19. So totally 2 different answers. So that is the purpose of PEMDAS, and we're going to be using that in this first problem. So the first problem is 2 times x plus 4 is equal to 4 times 2 in parentheses. The parentheses are important to show like how they want it written, because like, you know how I wrote that other problem? It was confusing. You couldn't tell where the 3 was supposed to be added. You couldn't tell where the 4 was multiplying with. So that's the point of parentheses. So first we're going to just do this. So 2 times x is just x. Plus, you have to distribute. You have to go to each number. You can't just add x plus 4. Obviously, you can't because this is a variable. You can't add it to 4. Remember, apples and oranges. 4 is an orange, x is an apple. So you need to distribute this outside number, outside term, to both of them. You can't just do it to the x and add 4. You have to remember to distribute. So 2x plus, and then you go 2 times 4. That's the point of parentheses, to show that something from the outside is multiplying with the inside. So 2 times 4 is 8. That's equal to 4 times, and again, the point of this parentheses, you distribute this whole portion. It would be 2x. And since there's a minus here, in my previous video, I talked about the negative and positive rules for multiplying, where if you multiply a positive number and a negative number, it still stays negative. So a positive 2 multiplied by, this minus is not alone. It's with the value after it. So it'll be 2 times negative 2, not just 2. 2 times negative 2, which is 4, negative 4. Minus, and then 2x right here. Now, what you need to do is keep this, just bring it down, we'll equal it right there. You, again, now have to distribute these together. So, again, you're distributing. The multiplication is the same thing as having parentheses. That basically equals 4 times 2x minus 4 minus 2x. Which, again, we're distributing. So remember, so now in this case, there's a number right beside the x, but it's the same thing. You just, instead of multiplying this 4 times x, you're going to multiply by the 2 and then just add an x beside it. So it'd be 8x minus, and then remember, it's minus because it's a negative number, because it's a positive times a negative. So 4 times 4 is 16, and since it's a negative 4 right here, you're going to just do negative 16. And then subtract 2 to leave you with 2x plus 8. So what we're solving for, actually, I forgot to mention this earlier, we are solving for x. We're not trying to figure out if these equations are similar or if they're the same. We're actually solving for x. So now we can arrange this side in a similar format where like you can put the x's together so it makes sense, and then we can add minus 16. Bring it down. So now these are like terms. So what's 8 minus 2? It's 6. So 6x minus 16 is equal to 2x plus 8. You just keep bringing down the values. Let me erase this. 2x plus, okay, 1 second. Okay. 2x plus 8 equals 6x minus 16. Okay, so now we are going to bring the x's to one side in order for it to subtract from each other, and then we can just solve for x. It's very similar to what I did in one of the past couple of videos. So in this case, we're going to bring x to this side because I always like to keep the x's positive or as positive as I can make it. So we're just going to subtract a 2 here, 2x and 2x. Because remember, once you subtract, it'll go to 0, so it's 0 plus 8, so the 8 is left alone. And so 6 minus 2 is a 4x, and then just bring down the 16. Now, you're just going to bring the 16 to this side because 16 is like a loner on this side. It doesn't fit in with the rest of the part of the equation. So we're just going to add 16 to make it 0 on this side. So 8 plus 16 is 24 equals 4x. Now what do? We have the x kind of alone. We still need to cross out this 4 right here, as you can see, to get the x like truly alone. So you just divide by 4 to cancel it and make it 1. So basically when you divide by 4 or by any number by itself, it becomes 1x, which is equal to just x. So 24 divided by 4 is 6, and that is equal to x. That was a long problem, but I think it was okay. Hopefully it wasn't too bad. We're going to try a different question. So in this question, it says, Claire bought just enough fencing to enclose either a rectangular garden or a triangular garden as shown. The two gardens are presented below. How many feet of fencing did she buy? So the feet is the x. So she wants to know how much feet she bought for like each. So it's very similar to what I did in a couple problems, like literally 2 problems ago, except we're just comparing 2 values and seeing how much feet she bought in one and how much feet she bought in the rest. Oh, and it also says x is equal to 3 right here. So what we're going to do now is she wants to know parameter. It's not area, it's parameter. So we're just going to add 3x minus 3 plus 3x minus 3, because remember there's 2 of them, one here, one here, and then we're going to add x minus 3 and also x minus 3, because it's also here and here. So now 3x plus 3x is 6x, and then a minus 3 plus a minus 3 stays negative because it's 2 minuses to 6, because it's like 3 plus 3, but you have the negative. And you're adding, on this side, it's 2x, and on this side, minus 3 and minus 3, also minus 6. So now you're going to bring the like terms together, 6x plus 2x, which is 8x, and then minus 6 plus a negative 6, which is equal to negative 6 minus 6, which is equal to negative 12. So the area of the first rectangle is a minus, oops, sorry, 1 second. Sorry, it was an 8x minus 12. So now, as I said previously, x is equal to 3, so we're just going to substitute in 3 right there to get 8 times 3, which is 24, minus 12, which is 12. So that's how much feet she had for the rectangle. So now she had 12 feet for the rectangle, so I'll just write that above so we don't forget. And now we're going to do the triangle. That's a really bad triangle, sorry. 2x minus 1, 2x minus 1. This seems to be isosceles triangle where 2 sides are the same. So now what we're going to do, same thing, we're just going to add it together. So 2x minus 1 plus 2x minus 1 plus 2x, 6x minus 2, replace the 3 in, so that becomes 18 minus 2, which is 16. Okay, so this would be much cheaper, the rectangle. Thank you guys so much. I hope you have a wonderful day, and I'll see you next time.